Then how to convert the transfer function into state space representation, that we have seen. Maybe any problem we have done?
No, sir. We just derived.
Only derivation. Okay, now we have to do the problems. Let us do now. Transfer function to state space. State space representation. Right. So state space representation. Right. So take the problem. Represent the given transfer function given transfer function into, so in controllable canonical form. In controllable canonical form. Also draw the state diagram. Draw the.
We did one question, sir, on this.
Sir, we did on this. Okay,
Yes,
one
yes.
problem.
Yes, sir.
What is the transfer function? We did. Pallavi, what is the transfer function we did? F s by u of s is equal to Pallavi. What is the problem?
I wrote it in some other books and I mistake.
Maybe we'll check it. I will write now. You just recall and tell me whether it is same or not.
Okay.
It is 3 by s power 4 plus s2s cube plus 3s plus 2. Is it this problem?
Yes, I think so, sir.
Okay, then I will take next one more problem and similar problem. I will check it. We'll take it similar problem. No issue. Pallavi, this is okay. This problem is not done now.
No, sir.
Yeah, we will see this. This is not the transfer function. The system, given system in controllable canonical form. This is a given differential equation. Now we have to first convert into transfer function. Then we should convert into controllable canonical form. Yes, we will see the solution. The given differential equation 2 dy d cube y by dt cube plus 4 d square y by dt square plus 6 dy by dt plus 3 is equal to 4 into u. Tell me how many state variables are there? How many state variables we should take?
Y and dy by dt.
Oh, here y is there, right? Okay. Y and
Dy by dt and d square y by dt square.
so total 3, yeah?
3. Yes, sir.
Okay, say x1, x2 and x3. Therefore, we write x1 is equal to y, dy by d, sorry, x2 is equal to dy by dx and x3 is equal to d square y by dt square. See, if you see, this is the first equation. From this dqy by dt cube is equal to x3 dot. So from this, we need to find out x3 dot is equal to what? This total, just throw that side. It is 4u minus 3x1 minus 6x2 minus 4x3 by 2. By 2 is there. So by 2 for everything by 2. Okay. So this can be written as here. If you start from x1 coefficient, it is 1.5. So it is minus 1.5 x1 and x2 coefficient is minus 6 by 3 means minus 3. So minus 3 x2, then x3 coefficient minus 4 by 2 minus 2 x3 and u coefficient 4 by 2 that is 2 plus 2u. Okay, this is x1, x2, x3 coefficients. Now from these three coefficients, what we can write the equation x1 dot x2 dot, better we'll take another page. Therefore x1 dot x2 dot x3 dot is equal to a 3 by 3 matrix x1 x2 x3 plus some input matrix into U. Okay, what is the A matrix then? From this x1 dot is equal to x2. That means it is x1 coefficient
0,
0.
1,
Yes,
0.
0. Next,
Next, 1, 0, 0, sir.
1 0 0. Next, how it is 1 0 0? X2 dot equation. It is x3.
X3 is
So
1, 0, 0, 1.
0 0 1. Next,
Minus 1.5, minus 3, minus 2.
right. Then B matrix
0, 0, 2.
0 0 2.
2.
Right. Therefore, this is the state. This is state equation. State equation. Then output equation y is equal to
X1.
always I'm doing these steps, but not required. It is fixed. It is fixed because of this output equation y is equal to in the matrix format. It is 3 by 3 matrix here, na A matrix. That's why it is 3 elements, 1 row, 3 columns into x1, x2, x3 plus d. D is 0 into u. Okay, this is the output equation. Over. Problem is done. So controllable canonical form, you know already this one.
Yes, sir.
If you want to write directly the control, if you remember the controllable canonical form, that is 0 1 0 and so on, 0 0 0 1 and so on, 0 and so on, minus an minus 1 minus an minus 2 and so on, minus a1. So if you remember this matrix, you can directly write down these values from the differential equation. From the differential equation directly, if you know it. If you can't identify from this, just take the Laplace transform both sides, then you will get. See, if you take this in the Laplace transform, you should write 2s cube, correct? For d cube, it is s cube plus 4s square plus 6s plus 3 into y of s is equal to 4 into u of s. Therefore, y of s by u of s is equal to 4 by 2s cube plus 4s square plus 6s plus 3. We know that here it should be 1. Therefore, if you take common 2 in the denominator and throw to numerator, it will become 2 divided by s cube plus 2s square plus 3s plus 1.5. Okay, this is the transfer function. From this, you can write here. This is an, sorry, this is a naught, then a1, a2, a3. Okay, you can check here directly. Here you can fill it. This is the A matrix. And B matrix, you know already in the canonical, controllable canonical format. 0 0 0 and so on. Last is a B naught. So here numerator is 2. That's it. So directly you can get A and B matrices from the differential equation. Of course, this output equation is fixed. This is same for all the canonical, controllable canonical format. When you have the transfer function in this format, that output equation is fixed. But size will be different based on the order of the system. But anyhow, you can easily write it without calculating it. Understood this?
Yes, sir.
So it's up to you whether you will derive everything or you can simply remember and substitute. It's up to you. Then we will see the next controllable canonical form. This is the first case in the controllable canonical form. In the controllable canonical form, there are two cases I told you already. In the first case, when the transfer function d of s is in this format, b naught by s power n plus a n minus 1 s power n minus 1 plus and so on plus a1 s plus, sorry, this is a naught, this is a1. This is a1 s power n minus 1 and so on an. So if we have this kind of transfer function, previously we have done this, how to solve the problem under controllable canonical format, and it's a state diagram we have seen in last class. Now in the second case, why don't this transfer function be a numerator polynomial and the denominator polynomial? It may be. Definitely, there is no guarantee that always numerator is a constant. There may be a chance s power m plus b1 s power m minus 1 plus and so on plus bn. Maybe like this. Okay, plus and so on plus an. This may be like this. So in this case, now we will see how to get the controllable canonical form and how to draw the state diagram. Okay, we'll see now the controllable canonical format of this form. Second case. So in this case, when y of s by u of s is equal to some b naught s power m and so on. For our simplicity, for the simplicity, I will take only third degree polynomial in the numerator and denominator. So it is b naught s cube plus b1 s square plus b2 s plus b3. Denominator is s cube plus a1 s square plus a2 s plus a3. Suppose say this is the given transfer function. Now we will calculate the controllable canonical format. In order to take the state variables, we need to get we will cross multiply this. Sorry, not cross multiply. We will multiply this total transfer function with the state variables. Say the state variable um, state is x of s. Okay. Okay, when you multiply this, the numerator will be b naught. Okay, I will write directly y of s is equal to from this numerator and u of s is the denominator. That way I will assume. Therefore, I can assume that y of s is equal to b naught s cube plus b1 s square plus b2 s plus b3 into x of s and u of s is equal to s cube plus a1 s square plus a2 s plus a3 into x of s Say this is equation, or say this is equation 1 and this is equation 2. From equation 2, we can, what we can write is the state variables we need to write in the, in terms of state variables and um, inputs u of s. So I will write this, I'll rewrite this equation 2. Second equation I will rewrite. Then it is u of s is equal to a3 s3 x of s, okay. uh, okay, s cube, it is the derivative forms. So okay, one thing I will do here, I need to get integral terms, so I will make it reverse. It's better. Before solving, I'll do in initially only, so there will be no confusion. Here itself I will do it before taking equation 1 and 2. Here this I can write it as, see both the polynomials, this means degrees of s are in the same order, then I can take it, I can take common s cube in the numerator and denominator, so I will get 1 here, so that I will get x of s is equal to something, so that will give my state. Therefore I will take common both in the numerator and denominator. Then this can be written as just b naught here, b naught plus b1. Here if you take s cube common, it will be s power minus 1 plus b2 s power minus 2 plus b3 s power minus 3 divided by into x of s whole divided by, here it is 1 plus a1 s power minus 1 plus a2 s power minus 2 plus a3 into a3 s power minus 3 into x of s. Now I will write y of s is equal to, now b naught into b naught plus b1 into s power minus 1 plus b2 into s power minus 2 plus b3 into s power minus 3 into x of s. Say this is equation 1, and similar way u of s is equal to 1 plus a1 s power minus 1 plus a2 into s power minus 2 plus a3 into s power minus 3 into x of s. Say this is equation number 2. Okay. Now from equation 2, I will multiply x of s. Therefore, I can write u of s is equal to x of s plus a1 plus a1 s power minus 1 a1 s power minus 1 x of s plus a2 s power minus 2 x of s plus a3 s power minus 3 into x of s. From this, what I want is the state x of s is equal to. Therefore, I can write this total through this side. U of s. Okay, I will write this. Okay, let it be like minus a1 s power minus 1 x of s minus a2 s power minus 2 x of s plus a3 s power minus 3 x of s. Okay, here now I need to assume what is the state variables. Here I will take it as x1 state variable, and this next derivative d by dt of this will give s into something, s into this one, that will give s power minus 2. So I'll assume this is a x2 and this is x3, I mean this total. Okay, and because of this one more time derivative x3 dot is equal to x of s only. Pallavi, understood this?
Yes, sir.
Any doubt here?
No,
I
sir.
have assumed this is x1, that first order derivative of this is equal to this one, because if you take first order derivative 1 s into s it will happen. So s power minus 3 into s will be s power minus 2. So this is the first order derivative. For this x2, first order derivative is this one. I said this is x3. And for this first order derivative is x3 dot, that is this one. I don't say this is x4 because we need only 3 variables because it is a third order system. Okay. From this equation, what I can write is, after assuming the state variables, this is x3 dot is equal to, now I will write in the order. This is minus a3 x1 minus a2 x2 minus a1 x3. Okay, and plus u. Correct? Maybe it is correct. No, from this we also know that x3 dot we got it, but what about x1 dot and x2 dot? From this this is the first order derivative of this, right? That means first order derivative of x1 is equal to this much, that is x2. So x1 dot is equal to x2, and similar way x2 dot, that means one time derivative if you do, you will get this, that means x3. So x2 dot is equal to x3. Therefore if you write the state equation from these 3 equations, x1 dot is equal to x2. Therefore x1 dot, x2 dot, x3 dot equation state matrix is equal to a 3 by 3 matrix into x1, x2, x3 plus a matrix, input matrix into u. Okay, later we'll see the output equation. First tell me this A equation, A matrix.
0, 1, 0.
0, 1, 0. Next,
0, 0, 1.
0, 0, 1. 0, 0, 1. Right. Next,
Minus A3, minus A2, minus A1.
very good. So it is nothing but a canonical form, last form only now.
Yes,
First
sir.
case, similar to first case, but B matrix.
0, 0, U.
0, 0, 1.
1. Sorry, sir.
See, this is changed, correct? Previously it was
Yes,
B
sir.
naught.
B naught.
Now it is fixed to 1. Whatever the numerator coefficients, leave it. It will come a fixed matrix. Only A matrix is changing based on the coefficients, denominator coefficients, but B matrix is fixed. Now we'll come to output equation. This is the state equation. Now come to output equation. Now come to output equation. Y of s from the first equation. We can write no similar way.
Yes, sir.
Tell me, see this. You have noted down, Pallavi? You have noted and right? First equation. Okay. Once again, we'll write first equation, not this. Y of s is equal to B3
B1.
B2 s power minus 1 plus B1 s power minus 2 plus B0 s power minus 3. Correct?
Yes, sir.
Reverse up.
Reverse we wrote.
Reverse is correct. So, reverse coefficient. Here it is. So it is B0, B1, B2, B3 into x of s. Now multiply this. B0 x of s plus B1 s power minus 1 x of s plus B2 s power minus 2 x of s plus B3 into s power minus 3 x of s. Right. Now tell me. This is equal to x1 now? This is x2, right? This is x3 and this is x3 dot, correct?
Yes, sir.
Yeah. Now you tell me substitution. B naught x3 dot. What is the equation for x3 dot?
A
This
minus A3x.
minus a.
A3x1
Yes.
minus A2x2
Very good.
minus A1x3 plus U.
Plus
X3.
right. Done. Then next B1 into x3 plus B2 into x2
X2.
plus
B3 into
B3.
X1.
Alvi, can you simplify this? Take common x1, something into x1 plus something into x2 plus something into x3, remaining u terms.
Okay.
Please simplify and tell me.
Sir,
Pallavi, tell me.
B3 minus B0 A3.
This is for this is for
Y.
y of s, correct?
Yes, sir.
Y,
Yes, sir.
y is equal to
In brackets, sir. B3 minus B0 A3 X1.
b naught
A3 into
x.
X1. X1 plus B2 minus B0 A2.
Okay.
X2, sir. Plus B1 minus B0 A1 X1
Right.
plus B0 U.
x3, right?
No, sir, X1. Oh, yes, sir, X3.
Which one is x1? Which one is x3? I think here it is x1. Here it is x3. Yeah. Check it.
X.
A3 it is x1. A3 it is x1. Here it is x3. Correct, I think.
Okay.
Correct, huh?
Yes, sir.
It is x3 current only. Current only. Okay. Next plus, I think
Next,
u.
x1, sorry, u b naught, sir.
B not u. Okay, right. Therefore, write in the matrix format. It is y is equal to matrix. It is a row matrix. Elements are b3 minus b naught a3. Second element is b2 minus b naught
B naught a,
a2.
b1 minus b naught a1. Second, x1, x2, x3.
Right. Plus b naught single element into u. Now see, C matrix and D matrix both are different. So if you remember this format, whatever, if it is not third order, next to what I can write, if it is a 4 by 1 matrix, sorry, 1 by 4 matrix, it will be one more factor,
b4 minus b naught a4.
right? That's it. So three more elements. This is the way in general you can write it. Okay. So this is the canonical controllable canonical form when the transfer function is having both numerator polynomial and denominator polynomial. Now for these two equations, we will draw the state diagram. This is output equation. Now we'll draw the state. For this state diagram, I'll put a node at the input side. Okay, I will say it is U, and at the output, I will make a node, another node that is called Y. Now in the middle, um, basically how many nodes are there means it depends on the, what is that, state variables. 1, 2, 3 state variables are there, and x1, x2, x3, and third one more we should write, that is for x3 dot. Okay, this many you should keep it in the middle. Now we will draw the diagram. See, for the first state equation, so output equation will do first. Output equation is equal to, it is something into, no, not from this. First x, these equations only will implement state equations. These equations will do first. X1 is equal to y. We have assumed it. Sorry, not like that. X1 dot is equal to x2. Means x2 is equal to x1 dot. X2 is equal to x1 dot. X3 is equal to x2 dot. That means in between this we'll have 1 by s. This is x1 dot. When you integrate it, you will get x1. Similar way from this to this, x2 dot here x2. So I should integrate it to get x2. Similar way here also, I should do integrate 1 by s. So x3 dot will become x3. Okay, this relation is done. Then what about x3? x1 dot x2 dot over x3 dot is equal to what? Minus a3 x1. Pallavi, can you tell this? x3 dot is equal to
Minus a3 x1, sir.
minus a3 x1
Then minus a2 x2.
minus
a2
a2
x2.
x1. Next a2 x2.
x2. Yes, sir.
Okay.
Then minus a1 x3.
A3 x2. minus A3
A1 X3
minus A1 X3, right?
and in U, sir.
And plus U.
Yes, sir.
So plus U directly. Coefficient is 1. Done. Then next, come to output equation y. Here, if you see directly this equation, this is looking very bigger. So we'll go front before simplification. Before simplification, what is there? This b dot x3 dot plus b1 x3 plus b2 x2 plus b3 x1. Okay, so we will implement this b naught x naught plus b1 x3 plus b2 x2 plus b3 x1. We'll implement this. It is very easy because I have x3 node, x3 dot node, x3 node, x2 node, x1 node. I can easily get this. Therefore, y is equal to first one from x3 dot I should get one signal with coefficient b not a what Pallavi?
Yes, sir. B naught.
Not. Okay. Next from x3 I have one signal that is what is this coefficient? B1. I think is it correct? Yeah. B x3 dot B naught, then B1, B2, B3. X3, so B1, 3 B1, correct. Next X2,
B2.
B2. Next X1,
B1.
B1. No, B3. B not B1, B2, B3.
Yes, sir. B3.
B3. So this is completely white. Done. So this is the state diagram of the controllable canonical form for the transfer function when it is having numerator and denominator both.